Hello students, welcome to this video where I'm going to go over an example in chapter 3. Example we're working on is question 22 and then 23. Question 22 gets us to formulate it, 23 gets us to answer it and or solve it, and then answer some questions based on the output. So this company, Burger Doodle franchise, wants to determine how many biscuits and sausage and ham biscuits to prepare each morning. So here's all their data. They're producing two items. So we have X1 and X2, and we have a labor constraint, sausage constraint, ham constraint, and flour constraint. And down in this section down here, it tells us how much of each constraint or each resource they have. So I'm going to switch screens so I can show you the Excel, and then switch that over there, make that bigger. There we go. So we're producing two items. It says that, look over here, this is what I'll do. I'm so smart. There we go. And oops, 1 second, should have had this done before, but what? Okay, and there we go. This is a little too big. Okay, so we have labor constraints. So we're going to add we're going to add our resources there. We have labor. It's 0.01 hours to make the sausage biscuit, and 0.024 hours to make the ham biscuit. Other constraint we have is the amount of sausage in pounds. Of course, it takes 0.1 pounds per biscuit. We have a ham resource and a constraint that basically says 0.5. I'm getting these numbers from here. And then we have the amount of flour that they use in making those two items, 0.04 each. 0.04 and 0.04. The values in white, these are equations that we need to help us solve the problem using solver. All of our constraints are going to be less than an equal sign. So we're just going to enter this here. It doesn't change anything in the process, but it helps us remember what constraints we need to add in the solver tool. The right-hand side is basically the statement down here. We have 6 hours of labor. And don't be concerned that this is producing a number in this column H, the leftover column. Sausage, we have 30 pounds. Ham, we have 30 pounds. And the manager also purchased 16 pounds of flour. Okay, those are the resources and the constraints that we have. We need to enter in the objective function, the coefficients in our objective function. The profit, it says here, down here, the profit for sausage biscuit is 60 cents. And the profit for ham biscuit is 50 cents. Okay, that's basically, we have done question 22. We have formulated that linear programming model for this problem. We have formulated it using solver process. And now question 23 is getting us to solve it and then some answers, some questions based on that. So let's enlarge this. Let's bring up solver. Remember, solver is under the data tab, which you may have to add in from the file options menu. So solver, the objective function is what we're trying to maximize. In this case, we're trying to maximize profit. So it's going to be 14. By changing values in the amount of items we produce. Right now those items are 0, blank. So of course our profit is 0. And we have 4 constraints that we need to add. Let's go ahead and add these. We add these constraints by having the cell reference in for the usage, how much we're going to use, with the correct sign, and that's why we include the sign here, just to help us remember what sign to put in here. This is the key one. And then the constraint is basically the value in column G. We have 6 hours available to us. So we want to add that, and we want to carry on with the second constraint, usage for row 7, less than the constraint we have 30. Add that. For the third constraint, or ham constraint, we have that as our usage. It's less than. Constraint is also 30. Add. And then the last constraint, the amount of flour. And we have 16 pounds of flour. After we've entered the last constraint, we can press OK. Make sure that the last one's checked, that the constraints, the optimal solution is going to be non-negative. And solving through simplex LP. Let's go ahead and solve this. We want an answer and a sensitivity report. We click OK. And before we do that, we've already more or less answered our question. We're going to produce 300 sausage biscuits and 100 ham biscuits, and we'll have a profit of $230 in that day. And there's some leftover. And there's some constraints, resources with 0 left over. These become key as we go forward in our discussion. So as soon as we run solver, it's going to give us that answer. We can click OK. We get the summary reports here, sensitivity report, and our answer report. So let's make this sheet bigger as well, so everyone can see it. Okay, so we have solved it. We know that we are going to produce 300 sausage biscuits and 100 ham biscuits. We will have a profit of 230. So let's go through some of these questions that they ask us. How much extra, in 23A, how much extra sausage and ham is left over at the optimal solution point? Is there any idle labor time? So how much extra sausage? Well, sausage, extra, 0. This basically means that it is binding. The constraint is binding. A binding constraint, once more, is when the optimal solution is limited to that constraint. So there is no extra sausage. How much ham is left over? We have 15 pounds of ham. Because this is a non-zero number, this would be considered a non-binding constraint. We have more than we need. So because it's a less than and equal to constraint, this would be viewed as a slack variable, which means that we have 15 more than we needed. So because flour is also 0, flour would be binding, and this one here, our labor, non-binding. So to answer the question, how much extra sausage we have left? 0. How much ham is left? 15 pounds. Yep. And is there any idle labor time? Yes, 0.6 hours is left over. So roughly 0.6 of an hour, 36 minutes. Part B, what would the solution be if the profit for a ham biscuit were increased from 50 cents to 60 cents? So good question here. And because we're sitting in front of Excel, we can answer this using solver. But let's take a look at what we know about binding and non-binding constraints first of all. Basically, another way to ask this question, or what I like asking, is what would change and what would stay the same? We're changing the profit contribution from X2 or ham from 50 cents to 60 cents. Let's take a look at the sensitivity report for ham constraint, or ham coefficients, so which is found right here. We are producing 100 of them, and there is the objective function, 50 cents. It basically says we can increase it. Allowable increase is 10 cents, so we can increase it to 60 cents. Because the change is within the allowable increase, what will stay the same is the optimal solution of 300 and 100. Z will always change if you change the objective function. If your profit has increased from 50 cents to 60 cents, of course your profit will change. What will also stay the same are these binding and non-binding constraints. The constraints give us the shape of the optimal solution, shape of the optimal region. So we're not changing anything in here. All we're doing is changing one of these numbers. So we can verify that. Optimal solution is 300 and 100. If we change this to 0.6 and run it, just as a, we won't need any reports here, but look, it's still 300 and 100. Optimal solution has gone up by $10. It makes sense. We're producing 100 ham biscuits for an extra 10 cents, so that's an extra $10. The binding and non-binding constraints have stayed the same. So let's put this back and solve this again here. So we can get back to the original. Let's go back to our question. Part C. What would be the effect on the optimal solution if the manager could obtain 2 more pounds of flour? So instead of 16 pounds of flour, what happens if the manager is able to get 18 pounds of flour? So let's look at our sensitivity report for flour. There is the value. Let's go back for a second. Yeah, it's a binding constraint. That's how much we had available. Let's just color that. And that's how much we actually used. It is a binding constraint. The allowable increase is 1 pound of flour. We want to change it by 2 pounds. If we were only going to change it by 1 pound, our profit would increase by $12.50, the shadow price. If we were to bring in an extra pound of sausage, our profit contribution, our total profit would increase by $1, the shadow price for the sausage constraint. Note that there are no shadow prices for the non-binding constraints. For the binding constraints are 0. So the non-binding constraints, doesn't matter if we had more ham, we already have extra ham. So it's not going to affect it at all. So what happens if we change the flour from 16 pounds to 18 pounds? Once again, if it changes outside of the allowable increase and decrease, we don't know the answer. If it changed within, then the overall effect on the total profit is going to be the shadow price times the number of units we've changed it by. So if we were to decrease flour from 16 pounds to 14 pounds, we can decrease it by 4 units. If we decrease it by 2 pounds only, our total profit would decrease by 12.5 times 2. So what we can do to verify this is put in 18 for the available amount of flour we have. Because we're changing the constraints, what's going to change here is the shape of the optimal region, which means everything could change. Even if it were a change within the limits, it would still change what is binding and non-binding. So let's solve this. Data tab, solve, and click OK. Look at that. We're still producing 300 sausage biscuits, but only 125 ham biscuits, and there's our profit. And the constraints binding constraints are different.